Now we're going to do another example on relative rates. We're starting with a spherical balloon that is being inflated at a rate of 10 centimeters cubed per second, and we're trying to find how fast the radius is changing at the point when the radius is 5 centimeters. So we're starting with this balloon. We know that the radius is 5 centimeters long at the time that we're trying to find how fast the radius is changing. And we have the equation for the volume of a sphere, which is 4/3 pi r cubed. And we know that the volume is changing at a rate of 10. So that means that dV dt equals 10. And we also know that r equals 5. First, we're going to differentiate the equation for volume, starting with V equals 4/3 pi r cubed. Of course, the derivative of V is dV dt, and 4/3 pi stays the same since that's all constant. And now we use the power rule to find the derivative of r cubed, which is 3r squared. And then the chain rule means that we need to multiply the whole thing by dr dt. Now we're going to use our given information to find dr dt, which is the rate that the radius is changing. We have dV dt equals 10, and we also know that our radius is 5. So we found this equation in the previous step. This is the derivative. dV dt equals 4/3 pi times 3r squared times dr dt. So now if we just plug our values into the equation, we have 10, which is dV dt, equals 4/3 pi, 3 times the radius, which is 5, squared times dr dt. And you'll notice now that dr dt is the only unknown in our equation. So if we go through the algebraic steps, we find that dr dt equals 2/15 pi centimeters per second.